Welcome to The Circuit, the new face of the Concentrics podcast and your compass in the dynamic world of Concentrics. This season is called Tech Talk, where we will learn about AI, machine learning, neural network, and deep learning. Join us as we journey along the tracks of technology and customer experience in the advent of new trends. This is Tech Talk, where innovation meets consumer satisfaction in the digital age. Welcome to the Tech Talk microlearning session. We hope that at the end of this microlearning session, you will have a solid understanding of the fundamental concepts of artificial intelligence, basic machine learning principles, neural networks, and deep learning. And, of course, how each variable relates to the others. Let's get this started. First, let's understand the reason why the field of artificial intelligence emerged to further appreciate why AI is needed. The data economy has been one of the driving forces behind the rise of artificial intelligence. It relates to how much data has grown during the previous years and how much more it can grow in the coming years. The graph shows how the volume of information has risen throughout the years. As you can see, data has risen exponentially since 2010 thanks to social media platforms. The explosion of data has given rise to a new economy, and there is a constant battle for data ownership among companies to draw benefits from these huge data. To understand the need for AI, keep in mind that data has grown quickly in recent years and will continue to do so. As data quantities grow, data science is evolving toward a new paradigm in which robots can learn from data and extract important insights, paving the way for artificial intelligence. Let's start by hitting the big question. What is artificial intelligence? Imagine you wake up on a good day, ask Siri what the weather would be like.
Hey Siri, what is the weather like today?
The weather is partly cloudy with no chance of rain.
It's a good weather ahead, so you decide to drive your auto-driving car to work. You set it to autopilot so you can have a quiet commute to work. When you got home from work, you chose to watch the latest movie recommended by your favorite streaming app. If you think about it, AI makes our life easy. Voice-enabled virtual assistants on your mobile phone, auto-driving cars, and streaming applications that recommends movies or music that you might be interested in, are all using AI. With all of these instances, we can now answer the question, what is AI? Artificial intelligence is defined as intelligence demonstrated by machines that mimics human and animal intelligence. It is a logic-based technique for mimicking human intelligence. In a nutshell, artificial intelligence makes computers or machines think or act as humans. Artificial intelligence enables machines to adapt, reason, and recommend solutions based on the data at hand. Artificial intelligence is not new. In the 1950s, Alan Turing proposed a machine that can think like human. John McCarthy coined the term artificial intelligence and founded AI as a form of scientific field. It has evolved to a logic theorist program which allows machines to display their problem-solving abilities, which was created by Alan Newell and Herbert Simon. Arthur Samuel created the first computer that can play checkers competitively by learning from its own experience. The history of artificial intelligence is still being written, and we at Concentrics will be part of it, as we attempt to deploy cutting-edge technology using AI in revolutionizing customer experience. There are several types of artificial intelligence based on its capabilities and functionalities. First is the narrow AI, also known as weak AI. It is the stage where machines can perform a specific task. For instance, the recommendation on the streaming app like YouTube or Netflix, virtual assistants, chatbots, and spatial recommendation systems. Next is AGI or artificial general intelligence. This is sometimes referred to as strong AI, where artificial machine intelligence achieves human-level learning, perception, and cognitive flexibility. It picks up any intellectual capacity that a human can. Thanks to Llama 2 of Meta, Lambda of Google, IBM Watson, and GPT-4. We are halfway through effectively implementing artificial general intelligence. Artificial superintelligence, or ASI, is a term used to describe a hypothetical type of autonomous, self-aware, artificial intelligence that surpasses human intelligence. A good example is the use of artificial intelligence in movies. Artificial intelligence is also connected to machine learning, deep learning, and natural language processing. Machine learning is a subset of artificial intelligence. It is a process of automating and enhancing how computer learns from their experiences without human help. Let's discuss the basic of machine learning. When ordering food from an online food delivery app, Customer A always rates the food he orders from an online food delivery app based on the price, taste, and serving. To simplify and understand machine learning, let's place the amount of serving on the x-axis, which range from small to big serving, and price range on the y-axis, ranging from the price of food from the fast food chains to the price of food from the specialty restaurants. Let's have an example. Customer A prefers to buy food from restaurants that offer above average to large serving sizes at a low to average price. Customer A dislikes pricey foods with small serving sizes. Let's say we want to recommend a restaurant to Customer A. The restaurant has a good review in terms of the taste of food, has above average serving, and a below the usual price. What do you think? Will he be interested to try it? Definitely. This can be a good recommendation to Customer A, and it has a high probability of being liked by Customer A as well. This is the easy analysis for restaurant or food recommendations. On the same example, let's say that there is another restaurant that provides an average serving, with an above the average price that the customer spends when ordering online. In this example, Customer A has ordered to similar restaurants before. And if we go for the majority of his choices, we can say that Customer A will most likely order from this restaurant. When the choices become increasingly complex, machine learning comes into play. This is an example of a basic machine learning algorithm known as k-nearest neighbors. It means that the machines learn from the data using a prediction model, and when new data comes in, they can simply predict it. As a result, the more data that is consumed, the better the model and higher accuracy of prediction. There are several ways that the machine can learn. It can be supervised learning, unsupervised learning, or reinforcement learning. Supervised learning means that the system learns from labeled data, so you already know what the output will be. For example, you wish to create a machine that can classify coins. As a proof of concept, you intended to begin with the top 3 coins. Let us assume that a 5 peso coin weighs 7.4 grams, a 10 peso coin weighs 8 grams, and a 20 peso coin weighs 11.5 grams. You want your model to predict the value of the coin. In this example, the coin's weight becomes its feature, while the value of the coin will be the label. By feeding this data to a machine learning model, it can determine which features correspond to specific coin amounts. For example, it will learn that a coin weighing 11.5 grams is worth 20 pesos. Let's now look at unsupervised learning. Unsupervised learning means that machines learn from unlabeled data. It enables the machine to detect patterns and information without being told what to look for. In unsupervised learning, it has to figure it out on its own. It uses clustering algorithms to group things that are similar. This may reveal patterns that we may not see right away. For example, if a store wants to know what its customers wants to buy, unsupervised learning can help by tracking and grouping the spending patterns. The store can use this information to create ads and create more appealing sale offers. Now that we know about supervised and unsupervised learning, let's now take a look at reinforcement learning. Reinforcement learning focuses on training computers to make optimal decisions by interacting with their environment. It's about learning optimal behavior in an environment to gain maximum reward. Optimal behavior is learned through interaction with the environment and observations on how it responds. The major elements for reinforcement learning are the agent or the learner, the environment, the policy that the learner follows, and the signals that the agent observes upon taking action. Reinforcement learning is used in robotics, playing complex games, and self-driving cars. At this point, we've discussed artificial intelligence, which is a technique that allows machines to mimic human actions. Machine learning is a subset of artificial intelligence that focuses on achieving artificial intelligence through data-driven algorithms. Now, let's dive to deep learning. Deep learning is a subset of machine learning that is inspired by the structure of the human brain. If the brain structure is based in neurons, then the deep learning structure is known as an artificial neural network. Let's compare how machine learning will work from deep learning. Suppose we want to differentiate between apples and oranges. If we use machine learning, we must identify the features that distinguish apples from oranges and classify them accordingly. The features can be the color and the texture. The labels will be the name of the fruit. Using deep learning, the signals are taken up by neural networks without human intervention. An example of deep learning is the translation from different languages in seconds, using Google Translate. As the session concludes, we encourage you to learn more about artificial intelligence, machine learning, deep learning, and neural networks, so that you may stay up to date on the newest technological developments. Thank you for listening. That brings us to the end of the first micro-learning session. We hope you find the information valuable.